Want to create a particle flow that moves smoothly across a surface, following every ripple of a flag like this one? This is the final result, built with Cinema 4D's new particle system and rendered on iRender's multi-RTX 4090 GPU render farm. In today's video, I'll walk you through every step, from the mesh setup to getting particles to flow along the surface. With Cinema 4D's new particle system, simulating a flow of particles that follows a surface is now much easier than before. In this video, we'll simulate that particle flow on a moving surface to really put this new particle system to the test. We start by creating a standard material in Cinema 4D and loading our prepared image into the material's color channel. We'll need this for the steps ahead. Next, create a plane object and increase the height and width segments. This gives us enough detail to turn it into a flag flowing in the wind. Apply a Jiggle Deformer to the flag, then add the dynamic forces we need, starting with a Turbulence Force. Fine-tune the surface motion by adjusting the springs parameter inside Jiggle, and control which area moves using a linear field linked to the Jiggle Deformer. Add a smoothing deformer on top, so the flag's motion looks smoother. Create the flagpole using a capsule object. And add one more wind force inside Jiggle. Now for the particle flow. First, create a vertex map on the flag's surface to control where the particles will be emitted from. Next, create a mesh emitter with its distribution mode set to follow the vertex map we just made. Adjust the particle's movement direction along the x-axis, so the flow starts at the flagpole and travels toward the far edge of the flag. Create a vertex color map, then apply a shader field using the same standard material from earlier, so the particles pick up the correct colors. Hit play to check. At this point, the particles are still being affected by the same dynamic forces we applied to the flag, so the motion isn't quite right yet. To fix that, create a separate particle group and move those dynamic forces into it as a subgroup. Now the particles flow smoothly in the exact direction we set. Apply a data mapper to control how the particle's velocity and lifetime change over time. Add a flock modifier to keep a natural spacing between the particles. Now it's time to apply the surface attract modifier to the particle flow. And don't forget to add a collider tag on the flag's surface so the modifier knows which surface to follow. At this point, the particle flow is following the surface of the flag as it flutters, exactly as intended. Add another turbulence force to the particles to make the motion feel more dynamic and natural. Use a field condition combined with a box field to remove any particles that drift too far away from the surface. Add one more field condition, combining a random field with a linear field to give the particle flow a controlled random color variation. Next, create a new vertex map. Apply the shader field we just made onto it and use the result to create a polygon selection on the flag's surface. Create a redshift matrix scattered onto the flag's surface, restricted to the exact area defined by the polygon selection. Don't forget to add a scale field combined with a plane effector to the redshift matrix to control the size of each scattered element across the flag's surface. Finally, fine-tune the parameters until you get the result you're happy with. And that's it. We've just simulated a particle flow following a moving surface entirely inside Cinema 4D. With just the new particle system, combined with the Jiggle Deformer, Dynamic Forces and a few field conditions, you can create a professional particle flow effect without any external plugins. If this video helped you, don't forget to hit like and subscribe to the iRender channel so you won't miss our next Cinema 4D and Redshift tutorials. The link to try out iRender's RTX 4090 GPU servers is in the description below. Go check it out today. In the next video, I'll show you how to optimize Redshift render times across multiple GPUs at once. Don't miss it. Thanks for watching, and see you in the next video.